Okay, we're going to start a new part of the class. We're going to do how to describe, how to explore, and how to compare data set. Okay, first of all, let's talk about the measure of center. The measure of center, which means we talk about where the center or the middle of the data locates, or what is that. So when we talk about the measure of center, we talk about the following: mean, median, and mode. Okay, so those are very important three M's: mean, median, mode. And there's a couple of other concepts, but we don't really care too much. And every time we talk about the measure of the center, or you can call the measurement of the central tendency, we talk about a mean, median, mode. Now, what is the definition of a mean? Mean is the arithmetic average. Average. Okay, what does that mean? That very easy. That means you add them up. You add all the numbers up and then divide it by the number of numbers. So you might want to refer that to average, but that's not the word that we use in statistics class. We always use mean. And this one is the middle value. And the mode is the most frequently occurred value. All right, we're going to go over this one by one. All right, now first of all, we talk about a mean. When we talk about a mean, there's a, I don't know if you remember, we use the X bar to show sample mean, right? And for population mean, we use mu, and that is the population mean. Okay, and for the sample size is a little lowercase n, and the population size is the capital letter N. And the formula looks like this: X bar will be sigma of X over N. Sigma of X, which means the sum of all the X values. There's another way to show, which is I, literal notation, I equals 1 to N Xi, and then over N. Okay, what it means here is we have all the data in the set. We have X1, X2, X3, and all the way to Xn. That's the n numbers in your data set. And then you just need to add them up, then divide it by n to get to the sample mean. That's what it means. Sometimes when you use like a Microsoft Word or Word, I think in the even PowerPoint or Excel, they don't have this kind of way to show it. You have, unless you use some very special editor. So they have like I equals 1 to N Xi. They have something look like this, and that was exactly the same as this one. So don't be confused when you see this I goes to the right here, I equals 1 to N, which is exactly the same thing. This is the better way. This is a very mathematical way to show the summation notation. Sigma I from 1 to N Xi. So that's the sum of all the Xi. So this is the formula for the sample mean. And for population mean, it's going to be look like this. It's mu equals, again, summation of X over population size, capital N. Or your I go from a 1 to the capital N, Xi, so there is a capital N, that's how many numbers are there. You add all the values up, divided by this N. All right, so that's how you calculate. This give you the formula or the equation to calculate the population mean or the sample mean. All right, now we are going to, I'm going to give you a simple example, a very simple example. There are only 5 numbers, okay? So this example, I have a sample data set. Sample data set. They are 2, 3, 5, 7, 8. So I have 5 numbers. So what you know is this n equals 5, isn't it? And I'll ask you to find the mean because this is the sample data set. So we're looking for mean and we use this x bar to show it. So that will be the summation of x, means you add all the x values together, divided by n. That will be 2 plus 3 plus 5 plus 7 plus 8 over n. Sorry, n is 5. And then 2, 3, 5 plus 5 is 10, 17, 25. So we have 25 over 5. So the mean or arithmetic average is 5. So that's it. So you did it. If I give you a population data set, you just use capital N here, and you can count. Maybe this is your population. So capital N is 5, and then here you're going to use x bar. Not, sorry, you're going to use mu, not x bar. All right. So let me get another piece of paper, and this is how to get the mean. All right. Now we are going to the next measurement, which is a median. Do you remember the definition that a median is the middle number? Yeah. And you always sort first. So I put this sort. You have to sort the data. All right. Now the number I gave you earlier, the example 2, 3, 5, 7, 8, I already sort them from the minimum to maximum, from smallest to greatest. So I already sorted. But sometimes when you see the data set is not sorted, then you have to sort, because you're not just go to the middle, find the number, stay in the middle. You have to sort first, then get the number in the middle. That's the right way to find a median. Now, you have 5 numbers. You already listed them from low to high. Where is the middle number? You can use your finger. See, you use your finger, do this. 1, 2, 3. Did you see that? This 5 is your middle number. So in this case, your median is 5. Okay? Now what about if I give you 2, 3, 5, 7, 8, 10? What are you going to do when you have 6 numbers? Again, use your finger, go from both ends to the middle. You go 1, 2. Now, you see the problem. I don't have a single number stayed in the middle. Instead, I have 2 numbers in the middle. Then, to find the median, take the average of them, which means add them up divided by 2. So in this case, your median will be 5 plus 7 over 2. So the median, it's a 6 for this data set. All right, now I give you a very easy formula here. When n is odd, okay, when n is odd, for example, here we have odd number. We have 1, 2, 3, 4, 5. We have 5 numbers, so n is 5, right? And the location of median equals n plus 1 over 2, and I put a little th here because that shows the position. So what you need to do is plug in n equals 5, because you have 5 numbers. So 5 plus 1, which is a 6, divided by 2, you get a 3. Sorry, I should put RD, so it's a third. The median is the third number, so 1, 2, 3, and that is your median. All right, now when n is even, like this case, right? Our n is a 6, so the location of median, you're going to have n over 2, this position, and n over 2 plus 1, and then you take the average. So n over 2 plus n over 2 plus 1 plus 1 over 2, over 2, because that will be your value of your median. Okay, now in this case, in this example, 2, 3, 5, 7, 8, 10, we have an n is an even number, right? N is a 6. So I do 6 over 2. 6 over 2 is a 3. And the 6 over 2, 3 plus 1, which is a 4. So the third plus a fourth. So here's the third plus the fourth. 1, 2, first, second, third, and the fourth. So average of these two. Okay, so can you remember this formula? And be very careful when you get a third and a fourth. It's not a 3 plus a 4 equals a 3 equals a 7 divided by 2, you get a 3.5. That's not the right way. We're talking about the value and the location. They're different. Okay, so be very careful. At the end, when you get the median, it should be a value. Okay, so that's mean and the median. The median, again, is the middle number, right? It's the middle number, and that means there's same amount of number above it and the same amount of the number below it. See, there are two numbers above 5 and two numbers below 5. And in this case, we got the median is a 6, so there are 3 numbers greater than 6, and there are 3 numbers less than 6. Now you see, you sort the data from smallest to largest and get the middle number, and that is your median. All right, now the last one is mode. All right, now if you have 2, 3, 5, 7, 8, if you have a data set look like this, there's no mode, okay, because all the number appeared just once. Even you have a 2, 2, 3, 3, 5, 5, 7, 7, 8, 8. Again, no mode. Okay. If you have a 2, 3, 5, 5, 7, 8, there's only one mode. And the mode is a 5. Okay, because 5 occurred twice. If you have a 2, 3, 3, 5, 5, 5, 7, 8. All right, now this 3 occurred twice, and this 5 occurred 3 times. So in this case, we have only one mode in this data set, and that is a 5 because that occurred 3 times. Now, so no mode or one mode, and you might have 2, 3, 3, 5, 5, 7, 8. If you have the data set look like this, you have 2 modes. Okay, we call this is bimodal, or two. You have 2 modes. And they are 3 and 5. Okay, give you one more example, the last one. 2, 3, 3, 5, 5, 7, 8, 8. There are 3 modes in this case, so we might have multiple modes. That is a 3 and 5 and 8. Now you see, this is interesting, right? You might have no mode for a data set. You might have just one mode. You might have 2 modes. You might have more than 2, right? You have a multiple modes. So sometimes you have a data set, you might not have a mode. All right, now definitely you have a mean. Definitely you have a median, but not necessarily mode. All right, now we learned this, the measure of the center, mean, median, mode. Okay. Let's go back to mean, because I want to say something a little bit more than mean. It combined with the frequency table we learned earlier. Okay, if you have a data set, let's see, you have a 1, 3, 3, 5, 5, 5, 6, 9, 9. Okay, let's say you have this data set. You have a 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me just say add one more. Okay, so you have 10 numbers. That's your data set. And sometimes you already construct a frequency table. This is X. This is f of x, or frequency. Okay. In this case, I have a 1, just occurred once. I have a 3 twice. I have a 5 3 times. I have a 6 but just 1. And I have a 9 twice. And I have a 10 once. Alright, now if you are given a table look like this, you have the x value, but you have the frequency comes with it. Once you have the frequency greater than 1, that means this number appeared twice. So what you should do is you have to use the x times the frequency of it. So you get the subtotal of this 3 and 3, 5, 5, 5, right? So you use this, multiply by that. You have a 1, you have a 3 times 2, which is a 6. Now you see, how do I get this 3 times 2? Because I have 2 3's. You add up, you should have a 3 plus a 3, which is a 6. And then you have 5, 5, 5, 3 times. So you get 5 times 3, which is 15. All right, now 6 times 1, that's 1. And 9 occurred twice, so it's 18. And then the last one is a 10. All right, now if you add all those numbers together, then that will be your real total of 10 numbers. You see, you add the frequencies together, 1 plus 2, which is a 3, plus a 3, it's a 6, 7, 8, 9, 10. That is your n, right? Your n is 10. Let's say this is the sample data. And then now you're going to add all those numbers together. So 7, and then 22, 23, and 23, 41, 51. So the total is 51. All right, now in this case, our x bar will be just summation of x times the frequency of x over n, or you can say summation of x times f of x divided by the summation of f of x. That frequency column add up to n, sample size. All right, so in our case, our x bar will be 51 over 10. So my answer is a 5.1. Okay, if you just go back to the original data set, you have a 1 plus a 3, 4, and then plus a 3, you get a 7, 7, and then that's 22, 27, 32, 38, right? 38. Did I get that right? So 1, that's a 7, and that's 22, and then plus a 6. Here. Sorry, so that should be 56. Okay, so 56. See, I made a mistake sometimes. And so that's 5.6. All right, so the same thing if you just simply just add them up. I just quickly go this. So 1 plus 3 is a 4, plus a 3 is 7, and then that is a 12, 17, 22, 28, 20, 37, 46, and 56. Phew, I got that right. So the sum of 56, and I get this. All right, so this shows you if you're given the x value and comes with its frequency, how should you do that? You just use the x and multiply by its frequency. At the end, you add all those products together. All right, so that's a little special case. And there's another case to get the mean. Okay, let's see if you remember something. Okay, so we have the x and also the frequency of x. This is the frequency, okay? If you, let's say, if you remember that we have put the numbers in the intervals, right? We get the class, we call that class, and then the class has a class width. So if you have the number from like a 0 to 10, okay? So this means all the values between 0 and 10, it could be 10 but not 0. And then we have a 10 to 20, and we have a 20 to 30. Let's see, that's your data set. And then they already put the numbers in the intervals. And then we have the frequency. See, we have 5 numbers between 0 and 10. We have 10 numbers between 10 and 20. And I have 15 numbers between 20 and 30. How do you find the mean if you're given this? Now, Do you remember in our histogram class that, or the relative frequency class, that we put the data, the original, the raw data into the different classes, and then by doing that, you're losing some information. Once you have this type of a frequency distribution, you lost the information, you can never recover it. You don't really know. There are 5 numbers between 0 and 10, but you don't know who they are. They might be 1, 1, 1, 1, 1. They might be 1, 2, 5, 8, 10. It could be anything, but we only know this. How do you find the mean if you're given the frequency table looks like this? Now, the tricky part is to find the midpoint. We're going to use the midpoint value, or the mid value of each interval, to represent that all the numbers in the interval. It's just one of the approximation. We cannot really do anything better. So from 0 to 10, the midpoint is 5. 10 to 20, the midpoint is 15. And this is 25. All right. Now, what I'm going to do is I'm going to treat this as my x, because I don't have the original information, and from this interval I just use the midpoint to represent the value, all the values in this. In this way I will get the approximate mean, but that's the only thing we can do. So I'm going to use this x times f of x. So 5 by 5, 25, and this is 150, and 15 by 25 is 375. All right, so the answer is going to be 550. The total here of all the totals, so our x bar will be 550 divided by, let's add the frequencies. So that's a 15, 15, this is a 30. So there are 30 numbers all together. Okay, so the answer is 18.3. That's the best you can do. There's really nothing else you can do, because you lost information when you are given this. You don't really have the information of the original data. All right, so I think that's pretty much everything we need to know how to calculate the mean, median, and the mode, mean, median, mode. All right, now after this, we can get a piece of paper again. All right, I would like to talk a little bit more about something. All right. Mean, median, mode. If you have time, you can go through my other PowerPoints for this part, and there is a little bit some suggestion for the number you have. If they're like integers, by the time you calculate a mean, you just keep 1 decimal places. And if your numbers are like with already 2 decimal places, when you calculate a mean and a median, and then you want to keep 3 decimal places. So mean and a median, we would prefer to let them carry 1 more decimal places than it's represented in the original set of values. Okay, so that's that. And a couple of more things that we want to know about the center, but we're not going to do too much here. And we might have the mid-range and the range. We do that later, but you don't really use that quite often. Okay, so the range is just the maximum value minus minimum value. It's not really talking about the center. They talk about the dispersion, or how wide the data spread out. And then there is one called a mid-range, one concept, and it's just the range divided by 2. I don't see people use this quite often when we talk about the center. All right, now I would like to use a little table to compare mean, median, and a mode. Now, first of all, is data must be quantitative. do I have to have quantitative data? Do you remember what is quantitative data? Those are those comes with numerical values and always comes with a unit or something like that, right? So we have the interval data and the ratio data, both are quantitative data. Okay, so if you want to calculate the mean, yes, there has to be, or you just put a yes. Yes, all the data must be quantitative. For median, well, if you can sort the data, that means you can compare them. You might think the ordinal data, we can also compare them. However, sometimes, do you remember when you have even number of numbers? Let's say the example I just gave you when n equals 6. You have to get the two middle guy and add them up divided by 2. You cannot do that if you just have the ordinal data. So for this one, the answer is also yes. Okay, for mode, it might not be. Say no, it's not necessary. Okay, for example, if I have 20 students in my class and I just ask, tell me the color of your eyes. Okay, so we get like a 5 students with brown eyes, 7 with black eyes, and 2 with blue, and I have 6 with other color. Okay, so then can you find the mode? Which color appeared most frequently? Yes, you can do that. So you're not when you try to talk about a mode, you're not talking about, it doesn't need to be quantitative data. All right, so that's one thing. And the second thing I want to talk about is there only one answer? Yes. Yes. For mean, yes, there's only one answer. For median, yes, there's only one answer. Mode, not necessarily, right? Why? Because do you remember that sometimes we have the data set that has no mode, sometimes we have a one mode, sometimes 2 or more than 2. All right, so do we use all data value? To get answer? For mean, the answer is yes, because I have to add every single number and then divide it by the number of numbers. So every single number, I use them. What about a median? Because median, you have a lot of numbers, you only care about the middle guy. So you don't really care about the numbers not in the middle. So the answer is no. Okay. And what about a mode? No, you're not using all numbers. Okay. So let me just put this, make it a little easier. All right, now another important concept is it resistant? Resistant. What does that mean? Is this resistant? It means, is this stable, or is that okay? Is this resistant to extreme value? Think about extreme value. For mean, the answer is no, because every single number, you change one number, even just a tiny little bit, then the mean changes, right? So the mean is not resistant. What about a median? Median, we talk about the middle number. For the number not in the middle, if it's in the higher end or lower end, you can change it. You can change it to whatever, no matter how big or how small they are. Okay, so the median will not change, so the answer is a yes. And what about mode? If you simply just add one extreme number, extremely high number or high value to the data set, the answer is yes. Okay, it is resistant. It doesn't care. The mode may still be the same. All right, so those are the comparison of this mean, median, mode in certain way, so you can get a better understanding about the center. And I think that's everything we should know about the center, or measures of center, or the central tendency.